All right, 19. What are the natures of the solutions of the quadratic equation negative 6x squared plus 3 equals negative 4x? So let's do this by hand, okay? So there's some things you're supposed to remember about by hand. It's about the discriminant. If b squared minus 4ac equals 0, there is one real repeated solution. They might use the word unique. If b squared minus 4ac is greater than 0, there are two real unique solutions. And then we have if b squared minus 4, I don't know why I put the 2 there. That must be off. If b squared minus 4ac is less than 0, there are two imaginary or complex, two imaginary solutions, and they are unique. So anyways, the by hand approach is to, first off, get this thing in standard form. You got to have standard form. So I would make it look like this: 0 equals 6x squared minus 4x minus 3. And then, of course, if I picture, you know what A, B, and C are. So we have a negative 4 squared minus 4 times 6 times a negative 3. That's going to be 16. Negative times negative is plus. 4 times 6 is 24 times 3 is 72. And not that it matters, but this adds up to 88. So I'm in this situation. Two real unique solutions. So two different real solutions. Now, on a TI-84, I would still have to get, if I'm holding a TI-84, I don't actually have to know those properties, but I have to know what graphs look like, right? So I could have graphed it. That was 6x to the second minus 4x minus 3. Remember, solutions are where we cross the x-axis. So here's my graph, and it should cross twice. Wasn't so bad, no, it wasn't. Had the graph only crossed once, I don't know if I can make this one do it or not, but probably not. I can probably make it look close. And that's what they would really do. They would really pick something that looks ridiculously close. But that wasn't it either. But that one has only two imaginary solutions. So look at the graph, and the graph is going to determine what's going on. 20 is not in state standards, and it has not been for a long, long, long time. I mean, a long time. Wow. That's crazy. Give me a second. Last time we've done this in Algebra 2 is 2015. All right, so what I want to do, because I don't have time to teach you the old formulas, but I wanted to get them up in front of you. All right. So I had to pause real quick, go get an image. And this is what we're working with. Like I said, we haven't taught these things in years. So the person who's doing this has no idea what we teach in Tennessee. All right, so they gave me the form x equals. So that's going to be this guy right here. This is actually, sorry, they gave me the form x equals. This is what I always call it a sideways parabola. And you can see we have this funny form, y minus k squared equaled 4p x minus h. This was brutal on the average Algebra 2 kid. I mean, it was just brutal. That's why we pulled it. It was worse than logarithms to most kids. But because they talk about the directrix in that form, we need to be looking at this guy. This is actually a sideways parabola. It's called a horizontal parabola, which are not talked about anymore. The focus gives us the letters H and K. So I need this. And I forgot the P, didn't I? I need that P right there. So 4P x minus H. All right, so I have a directrix of x equals -1, and I know that this -1 lines up with h minus p. Okay, see that? -1? -1 must equal 5 minus p. So -1 must, sorry, losing it here. Subtract 5, -6 must equal -p. P is 6. That's my p-value. All right, let's start plugging some stuff in. Look at your form. Y minus 2 quantity squared equals 4 times p, which is 6, times x minus 5. And they have done some more math here than I think normally goes on. So let me look at their answer choices real quick. Yeah, they have gone around and they have solved this thing for x, is what they've done. Because it's a horizontal parabola, it has been solved for x. So it's going to look a little funny here. But anyways, this is going to give me a 24 when I do 4 times 6. Which I don't see on the other side. That's kind of interesting. I wonder if the turds have solved it for y. I don't think they have. Well, anyways, I'm going to divide that 4 out. That's going to give me x minus 5. And then I'm going to add 5. And I'm not going to get an answer choice. So this is really kind of messing with my head here. A lot. I should have x equals y minus 2 quantity squared over 24 plus 5, and I do not have that. That bugs me a lot. Nor do I see anything that is equivalent to that. See, I haven't done these or taught these in close to 10 years. But if the directrix is at -1, -1 would equal 5 minus p, so the p-value is 6. The equation is 4p x minus h quantity squared. I wonder if there was a typo made on this one. That is a very good possibility. Let's see what they say the answer choice is and see if we can do some wrong math to get it. Let's see. TMTA-Math contests. It's also possible this is one of those that doesn't have a right answer. Every year there's about 2 of them that don't have a right answer. Every year. And they're literally, I don't know if they do it on purpose. I think they do. I think they're hoping kids don't answer the question just because that's how these things are scored. What number was that? That was 20. I don't know why I went through all that process. I could just looked at the key here. And they are saying number 20 in Algebra 2 is A. And I don't agree with that. But it does have the 12th, which is kind of cool. So what have I done? All right, let me pause and think. Well, I'm going to leave this on here. It just occurred to me that I'm a complete idiot. I thought they gave the vertex. They didn't. They gave the focus. That's what they gave. They gave the focus at 5, 2. All right, so I'm an idiot. All right, so it's okay if you saw me make a mistake. I am not perfect. But they gave us a focus. That's what messed me all up. They didn't give us a vertex, they gave us focus. So if you'll look, you'll see that the focus, if you'll just glance over here, is at h plus p comma k. All right, focus is at h plus p comma k, and the directrix is x equals h minus p. All right, so there's enough information here to get what I need to be doing here. All right, so let's see here. The directrix is at x equals h minus p, and the focus is at h plus p comma k. So only thing I really know for sure about the vertex then, because h and k are your vertex. That's what they are. When I talk about my vertex, which I will need, I know that k is 2. That's all I know. So let's talk about this part. This part is 5. 5 must equal h plus p. Now let's talk about this. This is -1. -1 must equal h minus p. What you have is you have a, oh man, drop that, crack that, bummer. What you have is you have a very, very small linear system. It's very small. It's not that hard to solve either. If we will just take that away, we'll have 5 minus -1, which is 6, h minus h, which is nothing, and p minus the -p is 2p. We will get that p is 3. That was something I needed. Now, with that in mind, I can go back and I can plug some stuff in, okay? This piece, my focus is h plus p. So 5 must equal h plus 3, and h is 2. All right, cool. So lots of little things going on with a formula that you've never seen in your life and have never ever practiced. There's no way I could probably teach you how to cheat with this on a calculator that I can think of. I'm sure it probably exists. It's just we always did this stuff by hand, and I never thought too much about calculators back then. But anyways, I have h, and I put that 2 in the wrong spot. 2 is supposed to be here. Turns out it's also 2, because this was k. It's h comma k. Now we're going to go to this guy. I picked on that guy again because the directrix was given as a vertical equation. It's going to be y minus 2 quantity squared equals 4 times p, which was 3, times x minus h, which also happens to be 2. Now, what they have done is they have solved these for x's. You guys don't know this, but things that are graphed horizontally are solved for x. So this is going to be a 12. We're going to divide the 12 out, and you can already kind of get an idea of what we're looking at here. But we're going to have y minus 2 quantity squared over 12 equals x minus 2. And if I just shift that on over, I will get the first choice. So this is kind of nice. I got to do something I haven't done in a long time, a very long time. And it threw me for a loop. 21, what is the 20th term and the sum of the first 20 terms of a sequence that begins with 3, 6, 12, 24, and so forth? So I look at this thing and I realize that I am timesing by 2, which means my ratio is 2. This means that I am geometric. Okay? The explicit rule for a geometric sequence is that the nth term is the first term times r to the n minus 1. So if I want the 20th term, a sub 20, I'm going to be the first term of 3 times a ratio of 2, and it's going to be raised to the 20 minus 1 power. And it's going to be a big number. There ain't no doubt about it. How big? I don't know. We have a 3 times a 2, and it is roof-topped to the 19th power. So 1,572,000 some change. Oh, that's cool. I didn't even have to do the second part. So this is kind of cool. I never showed you guys this in class. We go to math, summation. Look at that. Now, I don't have an n key. I have an x equal 1. The stops at 20, 1 through 20 terms. And the rule is 3 times 2 raised to the x minus 1. And there's your sum. So the sum checks out too. I didn't show you that in class because it's not in Algebra 2 that you learn to use a TI-84 to do that kind of stuff. All right, 22. What are all values of x that satisfy y1 minus y2 equals y3 if y1 is 3x plus 6, y2 is 4 times x minus 2 plus 3, and y3 is 7? I think what they're hoping is they're hoping you go straight to y equals. That's what I'm hoping they hope you do. But let's just set this thing up like it's y1 minus y2. 3x plus 6 minus y2, which is 4 times x minus 2 plus 3. Okay? And then it equals 7. I really hope they're thinking you'll go straight to y equals and just put y1, y2, and y3 and etc. in. And I'm sure that's an answer in there, but it's not how it's done. All right? All right, so we have 3x plus a 6. Let's clean up these parentheses. Minus, we'll have 4x minus 8 plus 3. Still equal to 7. I'm going to do a little more cleanup. This is going to be 4x minus 5. Still equal to 7. So I have 3x minus 6 minus 4x plus 5 equal to 7. 3x minus 4x is negative x. Negative 6 plus 5 is negative 1, still equal to 7. Negative x is 8, so x must be 8. Negative 8. Interesting. It's not on there. Which means Milbrath probably made a mistake, and I did. It was right there. No. Well, one there. 4x minus 8. Well, I'm like not doing so hot here lately. Maybe I should be taking a break. 3x. Why did that become negative? There's my issue. All right. Negative x equals negative 4. X is 4. And there's no I've never seen them do multiple select. So the only value that makes any sense is 4. And if I plug a 4 in, by the way, 3 times 4 is 12. That gives me 18. 4 minus 2 is 2. So 4 times 2 is 8 plus 3 is 11. And 18 minus 11 is in fact 7. So it's holding. And you can always go back to plug numbers in. Maybe they're hoping you do that. I don't know. All right. What is the solution set to the following inequality? This is probably best done with a graph, but I kind of want you to see the old school way of doing these things. This thing has 3 critical values. Critical values are things that you either can or can't be. X can be negative 7, x can be 8, but x cannot be 3. That comes from a use of the ZPP. That's what I did with the numerator. And then this was the idea earlier of a vertical asymptote, or you can't divide by 0. So those are 3 things that I know. All right, I know I can't be 3. Now, since I can't be 3, do you see that equality right there? This thing's gone. That's one of them. That's the only thing I'm going to take time to mark off. This is an old school technique of using a number line and plugging things in, and it kind of stinks. And obviously we will look at a graph. You are allowed to use a graph. All right, so I am allowed to be -7, solid dot. I'm allowed to be 8, solid dot. I am not allowed to be 3, open hole. And the old school technique is to test around things. So I'm going to test to the left, which is going to be -9. If I plug a -9 in, that becomes -2 times a -17, and it's sitting over a -12. So this becomes 34 over -12, which is negative. Okay? The deal was greater than 0. None of this matters. I notice that 0 lies between these two things, so I'm going to test 0. All right, if I plug a 0 in, this becomes 7 times a -8. And that becomes -3. This becomes -56 over -3, and this is positive, so it's going to be true. I get to keep all this crap. And the last thing I'm going to do is I'm going to test 4, see what happens to the right of that thing I couldn't be. So I test a 4. If I plug a 4 in, I get 11 times -4, sitting pretty over 1. And this is going to be -44, which is negative. So it fails the test. The only thing I can state is that I was stuck between -7 and 3. Now, the easiest way to do this is by looking at a graph. And hopefully, after you've seen me do the boring algebra, it'll make sense. So math, num, n over d. I then forgot what the equation was. It was x plus 7 times x minus 8. And that was sitting pretty over, what, x minus 3? Zoom 6, do the job. And it is a greater than or equal to symbol. So keep that in mind. It is a greater than or equal to symbol. And you can see that the graph is above 0 from here, and presumably it just keeps going and going and going forever until it hits some vertical asymptote. So that's kind of why it is the way it is. And yeah, boy, this wasn't bad for them to come up with because it's not that obvious what's going on. They actually did a halfway decent job on this. Let's take the y-min down to -1000 and the y-max to 1000 and see if it looks any better. Yeah, it looks a lot better. You can kind of see that you're above 0 and then suddenly you're not. So maybe there's some justification on that. Old school is still the best. Let's see here. Be careful on this one. It is a super easy problem. Oh, man. That stinks. It is a super, super easy problem. But they've done something kind of tricky that gets a lot of kids. This is the product of B times A. Even though you have a calculator, a lot of kids will miss it because you just don't think. And I'm guilty of it too. So here's the deal. For an m by n times an n by m, these two have to match. And the outside is the result. They're doing b times a. So they are taking a 2 by 2 and they are multiplying it by a, which is a 2 by 3. It is allowed. I think I saw Maddie do this the other day and I didn't catch it, but it is definitely allowed, okay? You're holding a TI-84. You do not have to do this by hand. So don't think you do. We're going to go to second matrix, edit, and A is a 2 by 3. And it is -1, 0, 1, -4, 1, 3. All right, back to matrix. Second matrix, math, edit B. B is a 2 by 2. You know, there's going to be a lot of kids who miss this question because they don't pay attention to detail. All right, we quit out. Second matrix, math, B. Second matrix, A. Order matters. So I'm looking for a row of negative 4, 1, 3. Choice E. What values for x satisfy the equation log base 5 of x plus 6 plus log base 5 of x minus 6 minus log base 5 of x equals 1? So, since old school is important, I know that a log of AB over CD is log A plus log B minus log C minus log D. I'm going to take these things right here and I am going to condense. I'm going to have a singular log base 5 and it will contain in the numerator x plus 6 times x minus 6. In the denominator it will contain an x and it will still equal 1. I'm also going to do log is bay. Okay, base is 5, it's raised to the first, and it equals this funny looking thing. X plus 6 times x minus 6, sitting pretty over an x. I'm going to counteract division with multiplication, that'll give me 5x, and I'm also going to handle this. If I FOIL that, that's x squared minus 36, which you should know if I took you, that's what it is. And now what I'm going to do is I'm going to one-side this thing. And by the way, it ain't going to be that thing. Well, I guess it could be. Odds are slim. And that's something that we can talk about too. We can, and I will. Anyways, one-sided, 0 equals x squared minus 5x minus 36. That will factor all day long. It'll factor. It's minus 9 and plus 4. Zero product property tells me x is 9 or x is negative 4. Now, this is a problem. It's a problem there and it's a problem there. For a log with an argument, the argument is greater than 0. The negative 4 failed, the 9 kept. I was going to try and show you how to do this by hand, but they didn't pick a very good, or by plugging in numbers, but they didn't pick a very good example. But let me show you something, because none of my regular kids are going to watch this. And very few of you that I take to the math contest are either. I'm going to go to math. I'm going to scroll on down to log base. Check this out. Log base 5, x plus 6. Notice I'm in y equal to, because why not? Plus math, log base, still a 5. It's an x minus a 6. And then we have minus log base 5 of x. So minus math, log base 5 of x, and that quantity equals 1. And then we do a zoom 6. Oh, almost out of time, man. Second trace 5. You have to press that cursor till you see your little thing show up. There she is. Enter, enter, enter. Ta-da! Done. I have 3 minutes to fifth period, and I ain't got enough time to do that one. So that was, what, 19 through 20?